Hello folks. Today we're going to do a little bit with exponential models. We are going to talk about the factor and the rate. These are kind of confusing for students, so we're going to talk about that today. First of all, hopefully we all recognize this. Since x is raised to a power, this is an exponential model, exponential function, and the a represents the initial value. And the b represents the factor. Okay, it represents the factor. The b has always been what you multiply or divide by. So, for example, just to refresh your memory on this, let's say we had a table with x's and y's. And let's make this 3, 6, 12, and 18. We're used to now looking here and going, okay, the pattern is we're multiplying by 2. So that is the growth factor, and we're used to plugging a 2 in there. So that's what a factor is. That's what we're multiplying by. Okay? The rate is not the same as the factor, and that's where the confusion comes in. We actually have to rewrite the b as either 1 plus r or 1 minus r so that we can pull that rate right out, because the r is the rate, and once we have that r, we want to multiply that by 100 to get it in a percent, okay? So the whole trick here is we're going to take what's in parentheses and we're going to write an equivalent expression. Equivalent means the same thing. It's going to have the same value. And once we do that, we can pull our r out, which stands for our rate. So, here we go. First of all, I'm just going to rewrite my equations down here so I remember what they are. We're going to write y equals a b raised to the x. And to rewrite the equivalent is where we're going to replace it with this 1 plus r or this 1 minus r. Okay, so we're going to rewrite that. So here we go. Initial amount is 5. That goes where the a is, and the growth factor is 1.25. So we're going to write our equation. Y equals initial amount is 5, and the factor is 1.25 raised to the x power. Okay, now the tricky part comes in here. We need to rewrite the 1.25 as 1 plus something or 1 minus something. So the rest of the equation doesn't really matter for what we're doing. So it needs to be 1 plus, and the reason why is this number is bigger than 1. So 1 plus what gives me 1.25? Well, it's 1 plus 0.25 raised to the x. So notice, folks, all I did was take my factor and rewrote it with a plus sign in it. And now that I've done that, this right here is my rate. So my rate is 0.25, and I'm going to multiply that by 100 to get 25%. And by the way, since the factor is bigger than 1, it is growth. So this is a 25% increase. Okay. Now, you guys normally don't have too much of a problem when you've got growth. You just pick out this right here, 0.25, and you say it's 25% growth. It's when we have decay that is confusing. So first off, let's go ahead and write our first equation with our factor in it. So initial amount is 3. Our factor is 0.75 raised to the x. Okay. Now we're going to write an equivalent equation. So we've got y equals 3, and I need to write either 1 plus something or 1 minus something that is equivalent to 0.75. Well, y'all, it's not 1 plus because this number is smaller than 1. So since the number is smaller than 1, it's 1 minus. And it's not 1 minus 0.75. 0.75 doesn't go there. What we do is we come to the calculator and we put 1 minus 0.75 to find out that 0.25 is what goes here. So let's slow down for a minute and just take a look at what just happened. The B and the 1 minus R must, okay, and they do, because 1 minus 0.25 is 0.75. So now that it's rewritten in this fashion, we can pull our rate right out. Our rate is 0.25, and I multiply by 100 to turn it into 25%. And this is actually a 25% decay because the factor was less than 1. Okay, so what we're going to do is, with that, we're going to let you all try these two. So teachers, if you would pause the video, and I would say pause it for about 3 minutes and let the students fill this out. And now we'll do the last two together. Okay, so hopefully maybe after you've done these, when I begin to do these again, maybe something will pop into your brains there and you'll figure out whether you did these right or not. So again, let's start here. We've got y equals, the initial amount is 5. The factor is 1.15 raised to the x, and I need to rewrite my expression as a 1 plus r or 1 minus. So since this, let's go ahead and write y equals 5. Okay, now since this is bigger than 1, it's 1 plus something, and it's 1 plus what? Well, it's 0.15 is the extra amount over 1. So notice, 1 plus 0.15 is equivalent to 1.15. That's why we call it an equivalent equation. And because I rewrote it in this fashion, this here is my rate. This is my rate. So it's 0.15, and I need to multiply by 100 to turn it into a percent. So that is a 15% growth rate. And the hard one, the one with decay. So let's write y equals, initial value is 9, 0.97 raised to the x. This is my factor. And now I need to rewrite an equivalent expression. So y equals 9. And I either need 1 plus a number or 1 minus a number. Well, this is smaller than 1, so it's going to be 1 minus something. And some of y'all can do this in your head, but all I'm going to do is put 1 minus 0.97 in the calculator to find out the 0.03 is what goes in here. Why? Because 1 minus 0.03 is 0.97. These are equivalent expressions. And now I can pull my rate right out. It's 0.03. And when I multiply by 100, it is a 3% decay rate. All right. All right. We're just going to practice this in a different way now. Notice here is your function where you've got your factor, and then here it is separated out. It's either going to be 1 plus r or 1 minus r, and this is where you can pull your rate out. So y'all notice this is my b, that is my factor. So I can go ahead and put that right here. That's what I would be multiplying by. Each term I would be multiplying by 1.17. Now y'all, in order to find the rate, I got to rewrite the 1.17 as 1 plus something or 1 minus something. So since the factor is bigger than 1, it's going to be 1 plus something, and it's going to be 1 plus 0.17. So this right here is my rate. I have to multiply it by 100, and it is a 17%. And is it growth or decay? Well, how do we know? my B is bigger than 1. So for growth, your B is bigger than 1. For decay, your B is less than 1. Okay, so, and we don't count the negatives, okay? It's like in between really 0 and 1. So this is going to be growth since this is bigger than 1. Okay, let's do one of the harder ones. Let's do the decay. See, this number is smaller than 1, so I automatically know this function is decaying. And now I need to write the equivalent expression, and this is where it gets kind of funky. It's smaller than 1, so this is 1 minus a number. And if I want to know what it is, I can pop it in 1 minus 0.87, and I get 0.13. Another way of looking at it is, can kind of see this as 87 cents. Well, what's left over from $1? Okay, if I have 87 cents left over from $1, then the missing part was 13. So that's kind of how I think of it. This plus this gives me $1. Okay? And now 0.13 is my rate, and when I turn it into a percent, that's 13%, and my factor is 0.87. All right? So now I want you all to do the last 3. And you're going to use what you learned after you do these last 3. You are actually going to answer the multiple choice questions. It is 4 multiple choice questions. All right. Have a good day.